Good afternoon, everybody, and thank you for joining us for this webinar on 3D printing or design at home. I am glad that you can join us today in these crazy, unprecedented times that we're all in right now. My name is Michelle Russell, and I am a STEM educator and trainer here at Next Wave STEM. And I am excited to bring you this webinar today. A few quick housekeeping items before we begin. My colleague Desmond Martin will be running the chat room. So if you have any questions throughout this presentation, please feel free to drop them in the chat. Or feel free to use the Q&A button. I'm sure many of you have used Zoom recently and maybe attended a few too many Zoom calls, but I promise you this one will be unlike any other, and you'll definitely walk away with some great information and some great resources to use with your students, or maybe even just for your own design. I know I find myself sometimes just jumping on TinkerCAD and doing some of my own 3D design just to clear my mind. So again, welcome. We'd love for you, as we begin today, to drop your name and some information about yourself, where you're from, what you teach in the chat, just so we can better understand who our audience is. So welcome. So today, like I said, we're going to discuss doing 3D printing at home. Just a little bit of background information about our company, Next Wave STEM. Next Wave STEM, we believe very strongly in educating students, and I would also add adults and teachers as well, into emerging technologies. So using emerging technologies. So we have curriculum, and we offer professional development on everything from, like today, 3D printing, drones, robotics as well. And so we're really excited to help prepare students for their future. It's no longer our future that we're preparing the students for. We're really preparing them to empower them to use these new exciting technologies to guide them into their future career, and to really help make a difference in the world. And I think we'll discuss a little bit more about this, but if you've seen the news, which I'm sure we all have, 3D printing really seems to be something that is helping with everything going on today as well. So that's kind of a little bit quick background about Next Wave STEM and what we believe in. So 3D printing, what is this thing called 3D printing? Well, the best way to describe a 3D printing is taking a design or an idea and designing it in a digital model. And then it uses a machine called a 3D printer to go ahead and print layer by layer by layer to create a physical object. I sometimes like to equate it to the idea of a glue gun. So in a glue gun, the user pushes out the glue that then they're able to put onto a poster or onto paper. With the 3D printing, the filament, which is what's used to create the 3D object, is used, it's pushed out and creating a design or creating an object. So that's a very brief, quick overview of what exactly is 3D printing. And I guess then we have to look a little bit further back and think about, well, where did it come from? What is the history of it? And 3D printing is a relatively newer technology in terms of technologies. And it dates back to about around 1980s-ish, when in Japan, they developed something, an additive manufacturing technique, which was used to do rapid prototyping. So a designer, a builder needed a bunch of different examples of something. They created this manufacturing technique to rapidly their design, their idea that they had. back in about 1984-ish, this file type called STL, which is stereolithography, comes into play. And this is really the game changer for 3D printing. The STL file is now something it's that can be created, and other different machines, kind of like an open source, can use it and print off of it. And then not too long ago then is when we really see the most common 3D printing technology is developed. And this rapid prototyping now is taken to a level and has grown to help further expand ideas. 3D printers, the growth of the 3D printer itself has changed. It started off as being kind of this very large, very expensive machine that, very large, very expensive machine that was only found in those higher end manufacturing in the factories, and costs hundreds of thousands of dollars. And today you could jump on Amazon and you could buy a 3D printer for about $150, and it's going to print relatively well. Now, the 3D printer itself, it's going to be smaller, and so your prototyping or your objects that you're creating aren't going to be, they're not going to be houses, they're not going to be bridges, but they're going to still give you that idea of from design to actual 3D printing objects. And what we're seeing now is many schools, perhaps your school, has a 3D printer sitting about in a room. Our hope is that after today, we can give you some ideas to take those 3D printers and use them in your classroom. And yeah, we're all kind of remote and not in our classroom now, but let's think about that one day when we get back in, how can we use a 3D printer? And for now, how can we help our students design in 3D, and give them some activities to work on when they're at home as well? So let's think about some examples. I think I used to be a math teacher, and I always used to ask my teachers, well, why would I need to know about that math item? Like, what's it going to do? Like, how am I going to use it in the future? And so how are our students or us going to use a 3D printer in the future? And on my screen right now, I'm just showing you on your screen 3 different examples that I think really kind of, to some degree, defy how 3D printing is being used. This very first example on the left, 3D printed masks, medical masks, or parts of a medical mask. This, I feel like every time I open up the news or I go on my Facebook page or whatever it may be, I'm seeing how my colleagues, are using 3D printers. They've brought them from their schools into their house, and now they're using them to print parts of medical masks that then they're donating to hospitals to keep the medical staff safe during this time. And I've seen everything from, I also saw just today a visor, a 3D printed visor that people were printing, again, to help keep the hair back for the medical staff during this time. Another way that I think is really changing how things are being done is 3D printing, again, more so in that medical field, but for prosthetics. And so this image of a hand in the middle, it's all 3D printed parts. And the parts then are assembled and sent off to companies or to medical facilities to help those who are missing limbs kind of regain the use of those limbs as well. And then the final image that I put up there is to show you kind of the possibilities of where 3D printing, it's not just, the first two, they use the filament that's called, it's PLA, it's a form of plastic in order to build. But what we're starting to see now is 3D printers being used to print, and they're using not the PLA, not the plastic, but they're using chocolate or they're using food. So the image here is a 3D printer that's printing out chocolate designs, and thinking like, what could that future hold? 3D printers now can print gold. They can print, so jewelry is being printed. They can be printed for wood, metals. So some houses are being used in architecture. Sorry about that. And so I sometimes just think, what is the future going to hold for our students? And what are they going to be able to 3D print? And that we can't now because we don't have the resources, but how can we better prepare them? And so that is where the designing comes into play. So 3D printing is, we can break it down into kind of 3 simple steps: the designing of it, the slicing, and the printing. So I'll start with the design in a moment, but let me just jump to the slicing. So think of it this way. So the design is where we're going to build, we're going to create a digital version of the object that we want to print. And once we create that digital version of the object we would like, we're going to have to slice it. And so slicing is when we're going to take the object and run it through, take the design, sorry, and run it through software to prepare it for the 3D printer. And this is, and so we're going to talk about kind of the slicing portion. And then the third part is the printing, which is also very exciting. And unfortunately, since our students and ourselves are all in different places, we might not have that 3D printer to print today. But it's something that we can look forward to when we head back into the schools and we head back to see our students as well as the actual printing. So starting with the design. So let's start with the design. Second. All right. So when we're designing, we're going to use a software, a CAD software. And CAD stands for Computer Aided Design. And this is used, again, another real world sorry about that. Architectures use it to design, to build things digitally. And there's many different softwares that one can use in CAD software. One of the top names for in the CAD software industry is Autodesk. And Autodesk has a wide variety of different applications that adults, students can use as well. We're going to use, and thanks to Desmond for putting it into the chat, we're going to use a free cloud-based software called TinkerCAD, and I'm going to show you that in a second. And TinkerCAD is great because with TinkerCAD, students can use it on any device. I had a first grader use TinkerCAD on an iPad. But you can also use it on a Chromebook, on a Mac, on a PC. Again, it is a web-based, cloud-based software. Other CAD softwares you may have heard of before are also SketchUp as well. And there's a whole bunch of other ones. But again, we're going to focus on TinkerCAD today. Again, TinkerCAD is from Autodesk. It is web-based, and it is simple enough for to get in and just start playing around with it. So let me switch screens to my TinkerCAD. So hang on one second. So making an account within TinkerCAD, TinkerCAD, you can sign in with your Google account if you have one. You can create a free account. As a teacher, you can create a classroom account and give students a code to sign in, and then they're connected to your classroom. I'm just right now signed in with my Google account. And when I sign in to my account, what you see right off the bat is my dashboard. And these are all different projects that I have created within TinkerCAD. And so to create a new design, I'm going to click Create New Design and give it a second to load. And when TinkerCAD opens up, what it shows you is the Workplane. So let me give you kind of a little overview of the different parts and what you see here. The first thing I want to point out, because being a former computer teacher, I always think it's important to make sure you name your file. It goes ahead and gives a pretty silly, funny name up here, and you can quickly change it by clicking into it and giving it a new title. Once you have given it a title, some other points to notice here. This is the Workplane right here. This is where you're going to work and you're going to build your design within here. By default, it is in millimeters. So you can see down here, millimeters. If you would like to change the units of measurement that it uses, you can click this Edit Grid and change it to inches or bricks. Bricks is kind of gives you this like Lego view, which is kind of a neat view. I prefer to work in inches. So I'm going to switch it to inches and then just click Update Grid. So now when I'm going to be designing and building and changing the sizes of things are going to change within the unit, in the unit of inches. So over here on the right side of the screen, you see I have some basic shapes that I can use. I'm going to start off by pulling the box, the red box over. So I click the box and drag it to my work plane. And now I have added the box to my design. And over here on the left-hand side now, I have some ways that I can look at it and move around. Really important to note that you're going to be and your students are going to be designing in the three-dimensional world. So the x-axis and the y-axis and the z, the ups and downs, are really important to kind of point out. And so that's how I can view, I can rotate around or orbit around to see my object from different viewpoints. Which takes some getting used to, but is really great to kind of see it from different viewpoints as well. I do have the zoom in and the zoom out as well as I'm orbiting around. So let's take a look at this box, this cube. They call it a box, I call it cube that I brought in is a 1 inch by 1 inch cube. And it also goes 1 inch up and down. And so as I click on these different boxes, I can see the direction. So if I wanted my cube to be a little bit bigger, I can drag it out. Another thing is I can actually click into the number boxes and give it a size. So if I want it to be a 2 inch box, you'll notice it just worked with the X and the Y. If I want to move it in the Z direction, that's that middle, I can click and I can drag it up or I can drag it down as well. Other things you may notice when I am moving around, when I'm clicked into this box, is I have rotating. So you can see when I move my mouse over here, I can actually rotate the box. It rotated it. I also have, again, depending on the view that you're looking at it, I also can then rotate it this way as well. So think about also, I think TinkerCAD is a great to use within these like in this designing and building. It can also be used for some math items as well. I'm gonna click delete and start over. Now the fun part, or it gets more exciting than just bringing in a box and changing the size. I can now add shapes to it to further build my 3D design. So I was trying to think of an example might be, maybe I'm gonna have the 3D, maybe I'm gonna build a house out of 3D shapes. And so this really, have your students start thinking through, well, what 3D shapes are needed in order to build this house? I just see I had a question. Did I say that it can be used for primary students? Definitely. I used TinkerCAD with a first grader, actually used it on the iPad, their dexterity, being able to use their fingers to move things around instead of the mouse and trackpad was great. So yes, you can definitely use this with primary students as well as high school students, all age students. So with my design, like I said, I'm gonna make a house. So I'm gonna start by creating kind of the base of my house. And now maybe I wanna bring in the roof of the house. So again, think of the 3D design. When I bring it in here, again, rotating, I want my roof to be a little bit longer. Now the problem is, or not the problem, but if I move my here, they're both on the same plane, to use the math term plane. They're both on the same plane. But what I want is I want my green roof to be on top of my red box or house space. So there's an arrow I'm going to pull up. And as you can see, rotating around, now I have a roof about on my house. Now, this is a beginning of use of TinkerCAD. We're going to be having some more webinars where we'll dive a little bit more into designing using TinkerCAD, but they do have where you can align and center things as well. So here I have a roof. And now I was thinking when I was planning this out before, maybe I would like to put in a chimney. So again, I want to pull up the chimney like that. And that's looking pretty good to me. The part that I think I'm missing is a door. And so you may be wondering, maybe not, but I'm going to tell you anyways. So we've been using this red box, but you'll notice there's also these like grayed out boxes and there's a cylinder here. And that is because those are holes. And so I'm going to make a door. I did this before as a test. Let's see. And so you can see my door, right, is there. So if I click the door and the, I guess, main base of the house, there is this scribble feature right here. And the scribble feature allows you to create your own design, draw with your finger. There's some text letters as well. Now we're in the basic shapes. Just want to show you some other shapes that they do have. They have, we were looking at this. earlier, like couches, and so to be used for interior design. So what about having your students design a house and like show us what their bed and design their bedroom that they would want inside? And all of these colors are customizable just within the design as well. And this was a new one that I noticed for this at home, is making things at home. There's pennies and pencils, toothpicks. And so maybe for rapid prototyping, design something within TinkerCAD and then bring it into the real world and use those real pennies or use those real toothpicks and build it with toothpicks after you've built it within TinkerCAD. Again, there's just many different shapes, and I definitely invite you to go ahead, make an account at TinkerCAD and give it a look. So we have just designed our house, and let me think. Okay, sorry, we have just designed our house. And so that was step one, was doing the design. So step one, I designed my house within here. Step two was then the slicing, or it was the preparing it for print. And so I need to get this file from TinkerCAD into a slicing software. Now, 3D printers, if you have one at your school, at home, they may recommend a slicer to use, and each one might have a different slicer. But what we have found is there is an online slicing program called Astro Print, and this is an open source, again, cloud-based software that you can slice with. So I would like to bring this 3D printed, or this house design, into a slicer to prepare it for printing. So up here, I have an export button. I'm going to click export. And when I get to the export, you'll see I have a couple of things, just want to note a couple of things. First of all, it's really important that when you're exporting your design, that you're exporting everything within the design. And so everything in the design. And here you can see I have different file types that I can export it as. Again, STL is the standard for 3D print. And you can also actually design in TinkerCAD for laser cutting as well. But in this case, I want to export it and bring it into Astro Print. So up here it says 3D print. And I am going to click the Astro Print button. And what it's now going to do is it's going to take my design. Once I log in, you do need an account for this. Let's see if it will let me do it. You do need an account for this. Oh no. Of course, let me try this again. I was in it earlier today. Gotta love technology. One second here. There you go. All right, now it decided to work. So once I get into Astro Print, sorry about that little confusion. Again, technology. Once I get into Astro Print, it says I need to select a project to import. It's that object that I just created. So I'm just going to click import to import it into my design library. And here you can see there's my house. And I'm going to go ahead and click print and slice. All right. Now for this, it's saying that the model is too large for my printer that's there. I'm not going to worry about this right now. I'm just going to say continue without resizing. So here you can see is my 3D print. And when we set up Astro Print, when you set up Astro Print, you actually can choose the printer that you're going to use to do your printing. Again, each printer, because of the sizes and everything, each printer can print up to a certain size. So right now I'm just on my mini Delta. And then I'm gonna go ahead and choose the print quality. I normally keep it at normal. And if an analogy of what the differences are, if you remember, if you've ever printed anything on like a dot on an older inkjet printer, and you've had the option of printing it as a draft or printing it as normal, and a draft uses less ink, here uses less ink. Here in here the normal is kind of like the normal, where the best is like it's going to use that solid, a lot more ink, a lot more, it's going to be a lot smoother and cleaner, where draft might have a couple of bumps in it. So there's where your different print qualities come in. Supports. Now, we didn't talk about supports earlier, and so let me see here. I'm going to stop my share for 1 second, because I think with a support, it would be great for me to just to give you a quick little overview of the supports and how you would need a support. So when you're designing in 3D print in a 3D world, if you think of it like this, so if I'm designing, my hand is like this. I make a box, and then on top of the box, maybe I want to put another box, my phone, like this, right? It doesn't make a mess. Another example would be if I always like to say, if I were to print my arm like this, if I were to print my arm, I have my body, it's straight, it's on there, but this part has nothing underneath it. So if you're printing layer by layer by layer, what's going to happen here? These objects are going to fall down. So that's where that idea of the support comes in. I hope that clears up a little bit about the supports. But let me switch back here. In my house then, if now back to my house that I created, this little overhang of the roof might need some supports, which is why the supports came on here. Because if it didn't have the supports, again, it would fall and I'd have kind of a little bit of a mess right there. So that's why the supports is turned on, and Astro Print knew that. You also have this right here, fill density. Now, fill density is what it looks like on the inside. Again, so more density would mean it'd be more filled in. And I think I can show an example. Let's see. No, not in here. So think of it as if a fill density of 20% means that there's going to be some holes. It's not going to be hollow. Normally there's shapes that help you build it, but it's also not going to be completely solid and filled in. And so for the most part, most times 3D printers print at about a 20% fill density, which is what this defaulted to. So I can make a couple of changes here. You saw I went into these advanced slicer settings. Like with anything, there are so many different ways you can change things around, but the basics of just keeping it simple, I can go ahead and then just click slice. So here are other objects that I have created to print within here, but here's that first 3D object that I just created, my house. And if I click, hang on. Sorry about that again. Here I can see This is, oh, so I'm just showing you, this is the preview of what it is when it makes the 3D print. When it makes the file available for print, it's going to be in G code. And so this is what I wanted to show you. So I'm going to zoom in. And here you can see, again, if you remember, I had this set at a 20% fill density. So here you can see that there are kind of like blocks that are based within here. There, it's a better way. So you can see it's making this pattern of diamonds almost, and then it's not 100% filled in. And as it's printing layer by layer by layer, which I'm moving up here, it's building on. And you can see this is like the top. So here was that base of my house. And then as I was filling up layer by layer by layer, now it filled it. This box right here would be my chimney, if we think back to that again. And that will give me my house. And the side, this part right here, kind of hard to see. Sorry, I'm trying to make it. This part right here would be those supports that I mentioned. Here you can also see the estimated print time and the estimated amount of filament. So let's think about this for a second. If this one house took about 4 hours, a lot of times we hear from teachers, and I think about when I talk with teachers is, for one house, it's 4 hours. How am I going to print all of my students' work? Well, that is where, if you want to print your students' work, what I would recommend doing at this point would be to be putting a variety of different, put a couple of the different designs onto the same print bed. So you can print 4 or 5 different projects all at one time on the print bed. Let it run overnight, maybe start it in the morning when you get in, and then let it run throughout the day and go from there. Now, I know I've kind of thrown out a lot of information. I'm going to pause for a second and just remind you that please feel free to enter any questions into the chat or into into the chat or into the question and answer, and we will definitely be able to answer those questions for you because there's a lot of information there. As I'm pausing for a second, I'm just going to go back into my TinkerCAD. The house is a good kind of like first example of something maybe you're going to have your students build because it's something that is made up of a couple of simple shapes. Another example, in our curriculum, we actually walk students through, and when we do professional development in-house with our teachers, we also have teachers build the Willis Tower. And so architecture is also a really interesting thing to look at, buildings, and to have students recreate buildings, houses, the Sears Tower, maybe a bridge in 3D design. And so here what you can see is a design I created of the Willis Tower, or I still call it the Sears Tower. And what's really great about the Willis Tower that makes it a fun, easy, three-dimensional design is that it is made up of, I can pull these out, 9 different cubes or boxes. It's actually 9 towers. I don't know if you knew that. I grew up in Chicago. I didn't know it until I started working for Next Wave STEM. Is that the Sears Tower is made up of 9 different towers. And when the towers come together, they create the Sears Tower, and there's different heights. And so you can actually create these scale drawings of the Sears Tower and have your students scale drawing them out. And so you can see we have these two towers in the middle that are taller, and work from there. So that's another really interesting thing that that your students can work at, is looking at architecture and then recreating it within this 3D design. Ooh, what a great question. How did you put the 9 towers together? Yes, I kind of did that pretty fast. I was using some backspace keys because I had it, but the idea behind it is if you take 3 cubes or boxes and put them together, you can, I'm just copying and duplicating them. So now I have 3 more, and then moving them to align them on the grid, and I can do it again. So here now I have, if you look at this, I have my 9 towers, or my 9 cubes. And then by extruding and pulling them up, I can change the height like so. The 9 towers, definitely, yes. The 9 towers were 9 separate, they were 9 separate boxes that then we put together. I'm connecting them together. They're not, and now I'm gonna change each size individually as well. And definitely, can you use this to do projects with area and perimeter? What a great idea. That was another question that just came through. What a great idea with areas and perimeter. Again, because of the fact that you can change, you can work within inches or you can work within millimeters. You can give your students projects. I've seen some examples of saying, I want you to create something that has a perimeter of 10 and an area of 30, and really kind of dig deeper into their mathematical skills and their critical thinking skills, which is awesome, which kind of brings us to my next slide. Let me switch back to my PowerPoint here. Great questions. I love them. Please keep them coming. Oh, will the tower, before I continue, will the tower print all connected, or will each one print separately? So the trick here is, as long as the pieces there's no space in between the pieces, they will print all together. So they have to be touching. And the other, and so one of the things that in our curriculum, and when we do this project with students and with teachers as well during PD, is we teach them to use the group function, which I had done when I made the door in my house, and really orbiting around your image to make sure that everything is connected, and almost even just a little bit of an overlap as well. So great question. I was saying, so we were, talking, I said, oh, this is a great kind of leeway into, someone had asked the question of, could we have students use area and perimeter and 3D printing? And I said, yes, that's great. Because really, the 3D design, the TinkerCAD, is really just almost kind of like a way to enhance and to help build and support these 21st century skills that we want our students to have. Maybe your school, or you're interested in building NGSS standards as well, mathematical, Common Core, mathematical. I mean, this kind of just hits those boxes, checks the boxes in so many different ways. So really having our students be able to think creatively. I'm a super big supporter and believe strongly in the critical thinking, the 4 C's: critical thinking, creativity, collaboration, communication. And to me, those are just as important as math and science skills and reading skills that our students need to develop. And so by using 3D printing and 3D design, it's really building those creativity skills. Again, thinking about how can they reimagine, or how can they link this idea they have in their head or this picture they saw of the Sears Tower and take that and create it within a 3D world. Or I had students who, I have an example, I don't know if you saw, it was on my dashboard, so it went pretty quickly for TinkerCAD. We challenged a group of students to create in 3D a basketball net, a hoop and a basketball net, something they were interested in. So really thinking creatively. And then also, how about that collaboration? Again, it is a little bit difficult to have more than one person manipulating a 3D shape at the same time. That unfortunately, TinkerCAD isn't set up that way, like a Google Docs and collaboration. But students can gather around a computer and they can discuss what they want and they can plan it out that way, and they can share communication-wise as well. Printing is great to be able to teach the design process as well. And it really is, it's really something that I think the students really get into and really, really just like want to learn more about. I was talking with my cousin the other day, and her daughter was thinking about, when we go to the grocery store, we're touching the bags, again, we're all washing our hands a million times and making sure things that we are eating and touching and whatever are cleaned. We go to the grocery store, we touch the bags. And so she went to her computer unassisted, all by herself, went online and designed in TinkerCAD a bag holder. I have a picture on my phone. I forgot to transfer it over to my computer, but a holder that like she could hold it like this and it would carry her bags for her. And I just start thinking of like what other problems can be solved, and that's where those engineering design standards really come in. What other problems can 3D printing solve? And if not now in this like immediate, if not now, maybe in the future, how can we further develop and add to the excitement of our students as well? And 3D printing really does that as well. So great questions. I think, do we have one? Oh, great. All right, so moving on. Again, keep those questions coming. Thanks for sticking with us. So like, where do we go from here? What are those next steps when you want to do 3D printing with your students? Well, first off, you'll be receiving an email later today and from us. And in the email will be a link for you to sign up to register to get access to our 3D printing curriculum and actually our drones curriculum as well. We know times right now are a little crazy and everybody could use a little extra hand. So take a look at our 3D printing curriculum, see how it can help you, see if it's something you want to, further bring to your students. We have those lessons like the Sears Tower lesson that I had mentioned before, as well as creating a keychain and creating stamps and just a wide variety of other ones. Also, at Next Wave STEM, not only do we offer curriculum, we do offer, like I said, professional development for teachers. And so, so if you visit nextwavestem.com/pages/professional development, again, this will be in the email you receive. You can sign up for future webinars. So we at this decided that every Tuesday and Thursday, we're going to offer some free webinars for for faculty, for teachers. So on Tuesdays, our focus is on drones. And on Thursday, our focus is on 3D printing. So check out this link. Again, it will be in the email. And attend one of our other free webinars. Also, when we hopefully over the summer and when we are all back to not being as socially distant as we are now, we have in-person professional development, and we'd love to invite you to come to one of our in-person professional developments to further explore some of these emerging technologies. Also, and back to this for a second, in the email you'll be receiving today is information, a form for you to fill out to get your ISB clock hours. So if you would like to fill that out and get those clock hours, you can do that as well. And then finally, we hope Desmond, thank you, Desmond, has been doing a great job. And I think Anne's asking questions. Oh, yes. So when to get your ISB clock hours, we will be providing the certificate as well. We want to stay in contact with you. And so it will be in the email as well, but feel free to reach out to Desmond. He's the program coordinator, and I apologize, I don't think I told you what his title was, but reach out to Desmond, reach out to myself, and we'd love to, further answer questions, further help you. We're all trying to navigate this new road of remote learning and teaching, and so let us be an asset and help you however you see fit. Also, you can find us on social media. We're on Twitter, we're on LinkedIn, we're on Instagram, we're on Facebook. Haven't done the TikTok yet, but who knows? But follow us, tweet us, tell your colleagues about us, because we really want to be that go-to. I mean, we love helping teachers and we love working with students. So please reach out and let us know what we can do to further help you as well. I think that I kind of went through everything kind of fast, so I know I'm a little bit early on the 1 hour time that we said, but any questions, anything that I am missing, let us know. Oh, also, another email address that I just want to mention is Jared. Jared is our school partnerships coordinator, or he's in charge of school partnerships, and so he is available if you want to, further talk with us on bringing us in. If you're in the Chicagoland area, we can work with your school on maybe doing some teaching for you guys. Again, we are here to help you and we want to be a resource. So thank you so much for joining us. Again, I know there was a lot of information in here. We will be sending emails, and feel free to reach out to us if we can be of any further assistance. And we hope to see you again for a webinar. Thank you. But the chat's open if anyone has questions. You could still help your son. Show him 3D printing, tons of things, build race cars. There are so many different ways you can go. All right, well, thank you for joining us. And again, we hope to see you in the future.